Hi there, and welcome to this Spud Smart webinar on the ins and outs of potato yield monitors. My name is Carrie Belanger, and I'm the editor of Spud Smart magazine and spudsmart.com, and today I'll be acting as your moderator. With increased input costs and skyrocketing land prices, margins are shrinking. It's never been more important to have a good handle on what's happening in your fields. Data generated from yield maps year after year provide insight on how to manage your crop to improve your profit margin, your yield, or both. Whether this is the first season or your fifth using a potato yield monitor, our guest speakers will make sure you're getting the most out of the technology. I'd like to thank our sponsors, McCain Foods and BASF, for their support. I'd also like to take care of a few housekeeping items at this time. This Spud Smart webinar is being recorded and will be made available on spudsmart.com following the event. For audio quality purposes, all microphones have been muted with the exception of the speakers, but we do welcome your input. If you have a question or comment, please share it in the chat box. Today we have two guest speakers. Bill Mankfeld is the Vice President of Sales and Marketing at GREENTRONICS, and Karen Tracy Cowan is the owner of AgTech GIS. Today, we plan to cover the importance of creating a plan for your potato yield monitoring on your farm, the significance and value of collecting data, what's involved with the installation and integration of potato yield monitors, practical tips on running your potato yield monitor, an overview of yield maps, data collection and software, and yield data tips. Please type your questions and or your comments into the chat box at any time during the webinar, also indicating to whom the question or comment is directed. At the end of the complete slide presentation, there will be an opportunity for each guest speaker to answer the questions posed in the chat box. Our first guest, Bill Mankfeld, was born and raised on a farm in the Netherlands. His parents owned a custom farm work business, so Bill has been working on a wide range of farming equipment since he was 10 years old. After emigrating to Canada in 1979, Bill completed a BSc and MSc in agronomy from the University of Guelph. In 1993, while working in the potato industry, Bill was approached by some growers from the Alliston, Ontario area to develop a yield monitor for their potato harvesters. Bill, with his brother and business partner Bert, began experimenting with the measurement of potato flow on a conveyor. In those early years, computers were slow and software was challenging. Yet, from an idea and a dream, GREENTRONICS was formed and has been going strong ever since, and is now celebrating its 25th year. Please take it away, Bill.
Well, hello everyone, and thank you, Carrie and Spud Smart, for the opportunity to present here on the yield monitor product that we do. Great to have you here as well, Karen. I look forward to your presentation, and thank you very much for our sponsors. It's wonderful to be able to do this. As you mentioned, Carrie, my brother Bert and I are partners in GREENTRONICS. Bert is an engineer. He has an electronics degree from Waterloo. Back during the mid-90s, when we took on that challenge to design a yield monitor for a potato harvester, we really didn't know whether it would work and whether it would end up being something that many growers would want. But it just seemed like a really great idea, and we were immediately enthusiastic ourselves, and so we set to work on the development in my garage actually for quite some time, and it came together. And after 25 years, we can honestly say that we're glad we stuck with it, even though there were really some very uncertain years. So we started with potato growers and potato harvesters, but the system actually works well in all kinds of different harvesters where crop moves on live conveyors. So today I want to cover a little bit about the potato yield monitors from the GREENTRONICS point of view. I want to talk a little bit about why you would want this technology, and Karen will flesh that out more. And I want to talk a bit about the hardware that's involved and how you set it up and install it, and what your problems might be and what you should be looking for to make this a success. So the first question that we had to answer ourselves when we started with this is why should I invest in potato yield monitoring? That's really the all-important question when we start thinking about this. Why should you try? And so there were a number of answers we had right at the start, and that was enough for us to decide to go forward. It's important for a grower to know what's going on in the field. That's very obvious. You can look at yield maps and look at the data and gain insights on how to manage the crop to improve your profits and your yields or both. Yield maps easily show the areas in the field that have higher and lower productivity levels. And I always am amazed to see the variability that exists in fields that, when you stand on the road and look at a field, you think, wow, that's really nice and uniform. And then when you look at a yield map, it's a very different story. You could look at those areas of high productivity and see if they can do better with different kind of management. You can look at areas of lower productivity and decide whether you should be cutting back on some input costs because the yield potential just isn't there. And what I really like is when people introduce sort of a break-even price in their mapping software so that you can generate a dollar and cents map, so to speak, so that your areas with high productivity will come up and show, and you can assign colors to this. We'll show you in green and blue, for instance, those are the areas that you made money, and the areas that didn't make you money will come up in red or yellow or something like that. But this is where yield mapping is really useful. So it's a tool that you use to make management decisions. It's no longer, well, it never really should be guesswork, but it's less guesswork if you have the data in front of you. It's also your report card. So you go all season long and you can take images with drones and you can look at your crop and you do all your scouting. But at the end of the day, you need to know what the yield was. And so a yield map is kind of like a report card. It tells you whether your management had the right benefits, whether you gained. And then yield maps now are widely used to control variable rate fertilizer application, for instance, or lime application. So that becomes part of precision management, and Karen will talk a lot more about that. But we have to acknowledge that with every choice you make on a farm, you have to put some thinking into that, and there are always some benefits, but there are also some barriers. And we've recognized these over the years and have had to deal with them ourselves. So here are some of them that we've often encountered from different people. Some people think that the hardware installation and maintenance is difficult. And I want to show you in the rest of the slideshow that isn't such a big worry. In the past, it's true that gathering and managing data was complex. The software just didn't lend itself very much to that. It wasn't very user friendly. And that's completely changed, and Karen will show that as well. We get questions about calibration and how you operate a yield monitor, and I'll address those in the next few slides. An important one is, and people raise this, and it's real. A yield monitor may not be accurate in heavy or wet soils or in fields that have a lot of rocks and clods. And that just makes sense because a yield monitor weighs everything that comes by. So you try to place it in the harvester where the crop is the cleanest after all the separation has happened, but there still may be some trash. I want to say that shouldn't be a dead stop for you on the decision whether you want to get a yield monitor or not. Not every field that you have is going to have problems, and those problems won't exist in every year. So you will still be able to get valuable data with the yield monitor in many fields and most years, but there will be some times when that isn't the case, and you need to be aware of that and treat those data with some caution. I talked about the software programs, and Karen can tell us a little bit more about what's available. Data really, with that new software, isn't that difficult to understand, and it definitely shouldn't be overwhelming. Potato yield monitors are costly. Well, yeah, that depends. There are so many costs on a farm. Um, really, it has to do with what you get out of it. And so I want to address some of that as we go along in the next few slides. So where do you begin? If you are thinking about getting yield monitor, where would you start? And I think it's absolute key to have a plan. If you fail to plan, then the success rate isn't going to be very good, and you'll be disappointed. So I think it's important to plan ahead and to ask yourself a lot of questions. So why do you want the yield monitor? What will you do with the data? Who will help you with the data? Who will help you with getting the hardware? Who will help you with the installation and the maintenance of that hardware? And you need to be aware a little bit about the components that are part of a yield monitor, like load cells and speed sensors and a connection to a GPS receiver and how you save and store data. So it's good to be aware of these things ahead of time so that when the time comes, you're ready, you know what to do, and you have a plan. And without that, it's sometimes a bit difficult for people. I can talk a little bit about practical tips for running the potato yield monitor, and I will do that in further slides further down. But Bert has done a fantastic job designing it so that most of that is really, really simple. So he's incorporated some test menus so that after you've installed the yield monitor, it's pretty easy to check whether you've done it right. There are some Tare calibrations you have to do, so the system needs to know what a conveyor weighs when it's running empty. And that's a step you have to complete, and you may have to change that and repeat that from time to time because conditions change. So, for instance, a belted chain running in dry soil doesn't build up much soil, but when you're running in wetter soil, you can have some dirt sticking to the bars, and that adds up weight, and so you need to do a Tare calibration so the system knows where zero is. You can check your load weights on the display. So if your typical load weight is 450 hundredweight in a truck and you see a truck come in with 700, then obviously something isn't quite right. So either you forgot to go next load when you started a new load, or there really is a problem. But that is a very simple number to look at to determine if things are working right. Of course, you can always call GREENTRONICS for help, and you can deal with our dealers. And you can find the dealers on the dealer map on our website. And you should talk to your agronomist. So if you're not doing the mapping and data analysis yourself, you will be doing that via an agronomist or a crop input specialist. And it's important to talk frequently to these people so they know what is coming and what you're planning to do and what you hope to gain from the information. Let's talk a little bit about the yield monitor. So a yield monitor at its base is really a set of load cells installed in a conveyor on a harvester. And here you see a picture of a Lenco harvester, and you would install that yield monitor in the conveyor after the airhead and after the hedgehog separators, where the crop is the cleanest. Here's a picture of a load cell. So load cells get installed. They can be installed inside the conveyor. In this case, that was the most practical way of doing it. And you can see here how the load cell is installed on a bracket that is mounted to the frame. And on the other end, the weighing end of the load cell has another little bracket that holds the roller, which in turn supports the traction belt of the belted chain. So if you have two traction belts on the belted chain, then you need two load cells. If you have three, you need three. And we can do four if you have crop moving on two separate conveyors. That's not very common. Here's another picture of a load cell. This one was installed on the outside of the conveyor, which I personally prefer to see. But the same components and the same type of installation. And you can see that it doesn't take a lot. You have to drill a couple of holes in the side frame, mount the bracket, you give yourself some up and down room. There are slot holes for that, and then you mount the load cell and the roller. And basically you typically end up reusing the roller that was there already. There's a couple of really important parts about yield monitor or load cell installation, and it's good to keep those in mind. One has to do with alignment, is very important. The other with clearance, and the third one to do with balance. But I'll start from the top. So load cells, the ones that we use, have a capacity of 250 pounds, and we pick that because that's a reasonable weight. So if somebody were to walk over the conveyor belt and step in the area where the load cells are, they're not likely to get broken. With a strong arm and a good wrench, you can overstress the load cells. So be careful with that when you're installing them. You don't go over the capacity and overstress them, because then they're no good and you have to buy a new one. The belt tension is a very important part to think about. So the load cell roller needs to be perfectly in line with the rollers before and after. Because if it isn't, then you're changing the belt tension, and then the belt tension itself becomes a component of how we see weight. And you don't want that, because that makes the system less accurate. So it's important to take a straight edge or level and make sure that you've got things lined up right when you do the installation. You want to keep the weigh-in rollers on the load cells well away from the drive shaft rollers or the end rollers, the idler rollers, and that's because sometimes there's a little bit of wobble to those rollers, and you don't want to have to deal with the up and down movement of the belted chain. It's going to mess over the data. So stay away from those. A couple of rollers away is usually plenty. You also want to make sure that the product that you're weighing is not rolling around or shifting in the area that you're weighing it. So if you're installing an inclined conveyor, for instance, like many harvesters have the conveyor to the truck, and it's a bit on an incline, and that's just fine. You can install in that, but just make sure that the flights on that belt are in good shape so that the potatoes don't all roll back, and that will mess over the accuracy. Typically on a harvester, the tilt angle of the conveyor is fixed, but sometimes it isn't. And so when the tilt angle of the conveyor that we have the load cells in is changing because you're raising it and lowering it, then you need a tilt sensor to automatically compensate for how that affects what the load cells see. There's a few more points. The load cell needs to have clearance, so you shouldn't mount it so that it's tight against the frame. It needs to be free from the frame, especially the weighing end of the load cell. And in this picture here, you see how the roller is on the inside of the frame, of course, underneath the belt, and it's mounted to the load cell on the outside. So you need good clearance around where that bolt goes through the frame. So if that bolt touches the frame, then the load cell doesn't see exactly what the weight is on top of the belt. That makes sense. And it's not hard to do, just something to keep in mind. As I said before, my personal preference is that the load cells should be mounted on the outside of the conveyor frame. That way they're a little bit less likely to get gummed up with dirt. It's also easier to run the cable in a safe place. There's an arrow on the weighing end of the load cell, and it should be pointing down. And it is, don't joke, it goes wrong sometimes, and you get negative numbers. So it's easy to check, though. And then there's a test menu on the console that you can go to see if you've installed the load cells right and that they're working properly. And those are fairly easy to do. You will see two numbers. They should be reasonably close together to tell you that the load cells are balanced properly. They each see 50% of the weight of the empty conveyor. And you can confirm that they're working properly by just pushing down a little bit on them, and you see the numbers change on screen. So here's what our console looks like. It's really simple. There's some arrow keys that you can use to change menus. You can cycle through the different menus and choose the one you want by pushing enter. And then there might be more menus. Bert's done a great job with that. It's something we have good comments on from different people. It's very user friendly, very intuitive. It's not hard to figure out how to run this. There is, you see that there's a USB key on top of it. We use a ruggedized USB key, and that's used to copy the data from internal memory to that USB key. So if you're not connected with a different system and you're storing all the data on a GREENTRONICS console, then at the end of the field or the harvest week or day or even season, you want to copy all the data to that USB stick so you can transfer it to a computer that has the mapping software. So here's a list of the data that we collect with the yield monitor. Of course, we're measuring yield, and you can choose your units, tons per acre, tons per hectare, pounds, kilos, that's up to you. We store longitude and latitude information. We can collect field and crop IDs, so you can set that up ahead of time. If you want on the console, you can name all your fields or give them numbers. And if you grow different varieties, you can name them. You can see load weights, and you will see that on the go beside you. You just watch the console and it will tell you how much you've accumulated in the truck that's beside you. You can also store and see running totals for the field or the varieties or test plots if you have them. And you can see that also for bins. There's some calibration info that we store on the data record inside the console. And we use that for diagnostics purposes. So if you ever had a problem with the calibration of the yield monitor and it was generating numbers that didn't make sense, and you can't figure out how to get that fixed, then you could copy the data, send a sample to us, and we can do some diagnostics to help you figure out what might be the problem. We also store date and time for each data record so that it's easy to track back and sort through later on. All our data are stored in what's called CSV, or comma separated value format. That's a format that most spreadsheet programs understand, and you can import them into spreadsheet programs to do some, you can do some checking of the numbers and remove outliers before you import into yield mapping software. But most yield mapping software programs can understand CSV format and import the whole file directly. So it makes it very easy for us and for the user as well to have that format. Over the years, we've had some opportunities to work with John Deere and with Trimble on integration of our system with theirs. That makes sense. So there are many growers who already use John Deere and Trimble software on the farm for managing data and generating reports.
Yeah, I was talking about the slide that shows the John Deere 2630 display, and saying that since July of this year, we've been able to do the same thing with the Gen 4 display with John Deere. This is the newer Trimble display, the TM2050, and we can basically do the same thing with it. We can stream data to it, so it shows a yield map in real time, and it will store data itself and display a report on the screen. And it can also, just like the John Deere system, it can upload that data to a cloud server or to a farm computer, so that it can become part of the software on the farm that shows how the farm is being used and where all kinds of data are being accumulated. So I want to go back a little bit and talk about some hardware. There are 5 main components to the yield monitor, and we've talked about the load cells and showed you some pictures of how those are installed. And I've also showed the console itself, a simple little box that sits in the cab, and it gives an indication of what's happening and stores the data. But there's also a shaft speed sensor on the harvester that tells us whether the conveyor is running and how fast it's running. We have a junction box on the harvester where different cables come together, and we have to have a connection to a GPS receiver. So we don't do the GPS receiver, lots of other great people do, but that's important to have that connection, and we provide the cables for that connection. So here you see a picture of the shaft speed sensor. It's a simple stainless steel sensor that picks up magnets that sit on the shaft and gives us an indication of whether the shaft is running and how fast it's turning. We provide a little bracket, stainless steel bracket, that helps you to mount it very easily. We provide little magnets that you can stick to the shaft. And some people use epoxy glue and tape, as in this case. Other people use the hose clamp that we send with it to clamp it to the shaft. It's up to the end user, really, whatever is more convenient. If you have a slow running shaft, so say less than 30 RPM, you might want to put 2 magnets on the shaft. So we put 2 in every kit. So you put them opposite each other. That way we get 2 pulses per shaft revolution. It helps things a little bit. This shows the junction box that comes with our kit. You can see the cable entries for the load cells. In this case, there's 4 load cells. And they're fastened to connectors on the circuit board. This still shows the older connectors. We've since gone to the type of connector with you push a little button basically that allows you to insert the cable and then let go, and it's firm in place. Each cable comes in with its own cable gland. That way you can very easily secure it. When you tighten the cable gland, the cable inside the case, it doesn't move. It doesn't pull on anything. There's some lights on the board. They're nice for diagnostic purposes. So the little green light tells us that the shaft speed sensor is working. The red light tells us we have power, and the orange light or yellow light tells us that we have communication with the console and the cab. Many people want to know about calibration, and this is one of the things that people are most concerned about. Worry that we don't understand it. How should this happen? How often do I do it? What if I don't do it right? And so on. If you've ever done a calibration on a grain yield monitor, this is very easy by comparison. So let that comfort you a little bit. The first step in the calibration is the Tare length calibration. So this basically sets the number of revolutions or the length over which the conveyor moves in order to establish for the system, where 0 is. So I don't know if I'm explaining that very well, but we just tell the computer, look, we want the conveyor to run for 1 revolution or 5 revolutions to give us enough data so that we know what that conveyor weighs when it's running empty. And that gives us our 0 or our baseline. Now you can imagine if you run that conveyor for only 2 feet or something, you might end up with data that are not very representative of the rest of the conveyor. So it's important to run it around at least once. But typically, I recommend to people to go 3 times or even more. And that depends a little bit on the conveyor itself, of course. If you have a conveyor with flights, those flights will over time deteriorate. So some flights are gone, some flights are broken. That changes what the conveyor weighs along its length. And in order to get a good reading on that, you have to run that belt quite a number of times around so that the system can figure out what the weight is with nothing on it. And so when you've done the Tare length calibration, then you go and do the Tare calibration. You go to that menu on the console or on the John Deere screen or Trimble screen. And you start the Tare calibration. So the conveyor must be running at that time. You just start, and it shows you percentage how far it's along. And when it gets to 100%, it tells you it's done. You press enter to save the new data. And then you have to do another step to confirm that it's working right. And I might get to that in a minute. I'll just finish off with this slide here. The next step is span calibration. So now you go and run a weight over the conveyor. And a known weight, for instance. You can use a block of wood if you like, and run it over so that you accumulate maybe 200 or 300 pounds. And then you enter that number in the span calibration menu, and that kind of sets a multiplier inside the console so that it knows that when it sees 300 pounds, well, that's 300 pounds. I hope that makes sense. Ideally, you do that with a truckload. So we can get within the ballpark by using a small weight. But the best way is to do that with an actual truckload. Go fill a truck, see what the monitor weight is, then go weigh it on a truck scale and enter the actual scale weight, and that sets the multiplier. If you need a tilt sensor, so some places that's necessary, we do the tilt calibration in the shop before we send the kit out. If you discover after the fact that you need a tilt sensor, we can send you that, but then you have to do a tilt calibration, which means you have to put the load cells on a level spot and go through the menus for that on the system. It's not very hard. It takes maybe 20 minutes. I want to talk a little bit more about the Tare calibration procedure. This gets us the most questions in our tech support line. So it's important to, before you start a Tare calibration, to make sure that the belt is actually empty. Now that's easy to figure out. You keep it running, then you go to the Tare calibration menu on the console, you press enter, that said before, and it comes to the end and you save it. Then the next step is really important. You have to confirm that it actually does know where zero is. And so you go into the run menu and you look at your load weight while the conveyor is running. And it should, of course, stay around zero. It might fluctuate a bit because the weight of the belt is not 100% consistent along its length. So you'll see some positive numbers, then you'll see some negative numbers. But after a few minutes, you should still be around zero. If you see it drifting off, positive or negative, consistently, then the Tare calibration isn't right. And the way to fix it is first to go and increase your Tare length calibration so it runs longer to do the Tare calibration, and try that out. And if that doesn't work, then we have a mechanical issue, and you need to look at load cell installation and revisit the alignment, the clearance, and the balance. So you should be seeing a slide now that has a red conveyor. This is on a Sputnik harvester. This Sputnik harvester has a tub in the front, in the boom, and you see the load cell installed on the conveyor that's inside that tub. And because that conveyor raises and lowers while that tub is sometimes filling, sometimes emptying, we need that small tilt sensor on there to automatically compensate for how the tilt angle affects what the load cells read. One other thing we can do, we've just started doing that maybe about 3 years ago. We've been experimenting with infrared sensors, and we think we found a really good one. We've had this one for, I think this is the third year that you see in the picture. So you can mount this on the harvester, on the boom, and it will measure the product temperature. So we'll give you an indication in the cab on the screen what those potatoes, how warm they are or cold. And that can be useful to the operator to, call ahead to the farm and say, look, we're getting pretty warm. We should be thinking about shutting down, or pretty cold, and we should wait till it warms up. That kind of thing. But the other thing we can do is we can map that temperature and make that an attribute on the map, and Karen can talk a little bit about that, how that would work. In our own system, you see a temperature map. We can generate a temperature map with our right trace system, and it looks like this. So you can see by the color where the temperature was fairly cool to where it got pretty warm, and actually almost borderline warm where harvest probably should have stopped. And that's important because you can then follow those loads into the storage, figure out roughly where they are, and keep an eye on those areas. And that obviously has an impact on quality issues and so on. Now you should see a slide of the John Deere monitor. With our ISOBUS option enabled. So with ISOBUS compatibility, we can put all the yield monitor menus on that John Deere screen or any other screen that offers a universal terminal or virtual terminal, some people call it. That's a very handy way of doing things because that screen is nice and big. It's a nice touch screen, just much more easy to work with in a sense compared to our little console. And it removes some cab clutter because you don't need that GREENTRONICS console in the cab. You can actually leave it on the harvester. So you should be seeing a slide now with a big box that sits on the harvester, and it has a console in it. There's a junction box, and you also see the John Deere application controller that's part of the yield documentation kit that John Deere provides to complete the integration between our yield monitor and their system. So that gives you some ideas of various options that are possible to make things more convenient. And that basically brings me to the end of my presentation. So I want to thank you for your attention, and I want to turn it over to Karen, and she will go through her slides and her presentation. Thank you very much.
Thank you so much, Bill, for your presentation. Our next guest is Karen Cowan. Karen launched AgTech GIS in 1995 to provide tools, information, support, and training services to the Canadian ag industry using GIS and web-based technologies. AgTech GIS has a 20-plus year history promoting products from Ag Leader Technology and other leading brands, always promoting solid tools to get quality data into the hands of decision makers. More than just a software reseller, Karen is a frontline user of ag-specific GIS software products to communicate soil sampling information, yield maps, imagery analysis, field-level topographic data, and variable rate prescriptions. Karen's career focus has been to develop mapping and data management competency for growers, consultants, and local agribusinesses through a personalized training approach. Audience members, Karen is also having some disruption of internet service today. So if she does drop off, we'll get her back as soon as possible. So now, Karen, over to you.
Well, thank you very much, Carrie. And Bill, it was great to hear your presentation and see all the progress that your hardware is making in this wonderful information space. I'm going to continue on the themes that Bill started, but before I launch into potato-specific stuff, most of you who are reading farm press or going to farm shows or going to learning opportunities are hearing all sorts of buzzwords like big data, machine learning, artificial intelligence, Internet of Things. And my big pre-statement is before we can benefit from big data and all the cool things that industry is learning by having masses of this interesting information, first I think we have to have small data. And I don't mean unimportant data, but I mean your data, which is on-farm data, thoughtfully collected, organized, and understood. And I think that the first beneficiary of any data should be you, the grower, and or you, the crop consultant or trusted advisor. So before we can have meaningful and artificial intelligence, we must cultivate what I call field intelligence. Don't have to rush out to the next big thing before we've mastered the things we already have, such as the awesome yield data potential that we can collect with a GREENTRONICS yield monitor. So equipment is important, and thank you, Bill, for taking us through. I got to learn some things myself about your newest systems. Having good equipment is crucial to good data collection, of course. So the whole idea of precision ag has been built on the concept that if we can measure and document crop and landscape differences where they occur, then we can manage those differences to our best agronomic, economic, and environmental benefit. Okay, so if we can collect it, we can learn from it. And this first map that's up on screen is just a raw potato yield map that I have presented as the start of our example. And this is, as I said, a raw one. What can this map do for me? I've collected it. I've invested in the technology on the harvester. I've now brought that information into the office where I can see it or visualize it. What can it actually do for me? Well, first of all, it can show us, and the most important thing is it shows us the response to the yield limiting factors in the field, whatever they might be. They can help verify our agronomic plan, i.e. we put a variety X in this section of the field or variety Y in another section of the field, and we need to compare their performance over time. The yield map cannot tell us why things happen. It can only show us where things were different. But the yield map will show us the location of those differences and the magnitude of those differences. Straight lines usually mean that it's a man-made influence, and irregular regions or zones are usually caused by some naturally occurring phenomena, soil type, topography, irrigation, and so forth. In this particular map, it's the burst from the previous map, you'll notice that there are 2 or 3 very horizontal-looking dark blue areas. Those I would consider man-made influences. In fact, we had some very inordinately high yielding or high recorded information in those 3 areas. So a man-made thing or artifact is happening in this field. And the rest of it might be a little more natural. So I've collected this data. Data is what makes the map. Bill explained that the monitors output a file in what we call a comma-separated values, or a CSV format. It's a glorified spreadsheet. So if you can picture in your mind a spreadsheet, the first column says longitude, the second column says latitude, then there's yield and whatever increments or measurement system are using, 100 weight per acre, for instance. Then there may be elevation, speed, and obviously now temperature, which is cool. All of those attributes or columns of data are really what makes this map. So as we bring it in, obviously we want to use the best calibrations right from the start in the field, in the machine. We can then use the map to improve the equipment. So if I see an anomaly or a problem in this raw map, I can very often go back to the system and tweak some of those calibrations or recalibrate the machine to make sure we're getting the best data. So good data always starts in the field. Well, what happens if that information, or what happens with that information? I haven't done anything agronomic with it yet, but where's the money in all the trouble we've gone to this point? Well, first of all, there's some operational efficiencies that we can get off of this data collection. If we're seeing instantaneous problems, so we're seeing that in that live yield map that might be on our John Deere or Trimble display, or we see it in a map, we can immediately fix it. We can go back and fix that before it becomes a season-long issue. It can also help us in other crucial operations monitoring, such as handling product placement, tendering, equipment functions such as fuel use, speed, pressure, swath widths, and so forth. By being able to see and address those issues more or less live in the field, we usually gain some operational efficiencies. Time is money, labor is money. Those gains may be small, but they're often numerous and incremental. So don't overlook that as a benefit of having this equipment. Back to the map. Once we have some good data, bringing it into a software can make it better. All of the maps that I am using and displaying for you today are made by a program from AgLeader called SMS, or the Spatial Management System. The same types of things can be done in many other farm management information systems or AgGIS systems. I happen to use SMS as my program of choice because it can do everything that I need to do and then some. So it's my big favorite. So what I've done here, if you can see on this map, there are a number of black lines highlighted. I have highlighted those man-made oddities that we noticed in this particular data collection. And by bringing it into the office, we can identify them, we can select them, and then we can fix them. By eliminating those anomalies, that same map that you saw in the very beginning with some big blue, extraordinarily high yielding areas, which were erroneous data, we have brought it back into a corrected situation by using the tools in SMS, and we are able to then reap the best data from the collected data. So that same original map is now reduced to this correct map by using the software. So eliminating areas is very simple. Here's another example of a map. And in this case, I've also asked the program, show me all of the data points that are, we'll say, ridiculously high or wrong. We just know that they're incorrect data collection. And chances are you can't see very many on your screen, but there are about 978 little points there that are erroneous or wrong. And so I can clean it, or I can scale it, or I can use it as a diagnostic tool to go back and refine my monitor calibrations or my setup. And obviously, the biggest thing is I can now store this map for future use. What we're looking for in our data is not just the second-by-second data capture that has interest and that is important, but we're more looking for data trends. We're trying to say, of these thousands and thousands of data points across the field for this data capture, how can I amalgamate that into some zones that help me understand what's happening this year and what I can use for future. So these zones can be used to create management zones for variable rate strategies. We can use them to formulate better yield goals, or we can use it to help us with on-farm research initiatives to compare products or practices. And we can also use these for calculating nutrient removals. One of the ways we work with yield data, not just from the potato monitors, but from all crop monitoring systems, is to do what we call normalizing the data. This is expressing the yield as percent of average instead of hundredweight per acre or bushels per acre or kilograms per hectare or whatever measurement system we're using. Yield as percent of average. This allows us to compare performance with all monitored crops, or we can compare year to year. The importance is looking for stability. Is this an area that is consistently 20% above average or consistently 20% below average? What is it that we see year to year? This increases our reliability for using these yield zones to create management zones that go past the year in question. Another tool we use when we bring it into a software is the multi-year average. So once you have your yield monitor and you've collected data for more than 1 year, or you have not only a potato yield monitor but other crop yield monitors, is we are able to meld these into multi-year averages to look for multi-year trends. It allows us for more refinement of those management zones, but also it's a cool tool for building a library of here's where all the good years, good producing years versus the bad year scenarios. So there's a number of things that we can do with multi-year averages. Once we get data into an AgGIS, the other cool thing we do with it, of course, is being able to overlay this data with other data. Since all activities we do in the field relate in some way, shape, or form to the ultimate yield, we have to question how many of these are mappable. If you have a GPS or GNSS system on your sprayer, you can put your spraying as applied maps over top, your planting, your tillage, your scouting, your soil sampling, tissue sampling, or irrigation. Anything that is being logged with position is able to be overlain and combined with the yield map to make more relationships apparent. Another cool thing, of course, that we can do, and this is a trick that SMS Advanced users are very excited about, is the fact that with only 2 mouse clicks, I get to make a 3D map. So anyone who has a GNSS system or GPS system on the roof of their cab, they are collecting topographic information, whether they know it or not. Even if you're only using your GPS antenna for, let's say, auto steer or guidance applications, you are collecting elevation data. And with the advent of high accuracy GPS systems, we certainly can get some very acceptable elevation data. So this is simply that field that I have shown you all along. I'm now looking at the topography or the elevations in a 3D model. The cool thing about looking at it in 3D, this is now the yield and the irrigation, the extent of the irrigation. I'm looking at that in 3D to look for relationships. And our different perspective also often gives us a different understanding of the data simply by looking at it in 3D. When we're working in 3D, we also can flip the field around to get our best look at it. What else, though, can we map in this at the same points? What does it look like when we put our soil sampling information over top, our tissue sampling information top, those special scouting notations that we have made, the planting data, everything that we can collect with in a georeferenced format can now be added to this to enrich our understanding of what's going on in the field. Different perspectives equals different meanings to me. Now I'm going to give your eyes a break from yield maps for a second just to show you how we can integrate that with other information that you're using. And this happens to be a vegetation index or an analyzed satellite image from this field taken mid-July of this particular growing season. So imagery is simply a snapshot in time, and it can reveal the critical indicators of crop health and development. This is obviously earlier on in the season. If we compare that image, I'm now going 2D, so it's easier for you to see. On the left is our satellite image on July 18th, and on the right is the ultimate yield map. So imagery shows us where things were different, and the yield map shows us, well, what was the end result of those differences throughout the season. It's our ultimate report card. There's this same field of vegetation index a month later. And while this is interesting, it's still not the same as the actual yield map or the final report card. Some of those zones we're seeing, the highest yielding is blue, the lowest yielding red. And in the satellite imagery, the highest vegetation is green and the lowest is red. We see some similarities, but it's not an equal equation. We see trends, but the yield map is our final result. How did it all unfold by the end of the season? In any ag software, we can use one map to make a next. This just happens to be a bare soil image that I'm showing you here. But it's just to preface the idea that whatever maps we have, we can start using those maps as backdrops for data collection. In this case, we can use grid or systematic placement, whatever our agronomic desire is. But when we have a yield map as a planning tool, we can actually use the historic performance as a backdrop for more in-depth soil sampling, or even more abbreviated soil sampling in some cases. So those red dots that I'd maybe planned with a previous map, I could now take those soil sample locations, move them around into a more efficient and a more illuminating arrangement so that I'm getting the best soil test extraction. And this goes for scouting spots, this goes for tissue sampling locations, anything that we can use a historic yield map for to help us guide the best data collection for other data. It's a very useful tool. I'm going to switch maps here. Previous one was a map from Ontario. This particular map is one from PEI. And so just to reiterate, machine collected data allows, once we get it into the software, allows us to clean it, scale it, use it diagnostically, and store it for the future. And this is really a raw map that I'm showing you here. Every little dot represents 1 second of data capture throughout this field. My next representation shows that I can highlight that. Again, best calibrations out in the field are important, but we use the tools in-house to clean that map up and take out those little oddball points that we don't need. What we then are, the end result is a map. This one is what we call a swath map. So I'm seeing swath width for each of the points, sort of fills it in. And it's still very scattered looking, but it allows us to pinpoint where the differences are. And we can start asking the big questions. Why are they different? Is this a naturally occurring phenomena? Are there varietal differences? What is my effective planting dates? Planting conditions? Are there nutrient deficiencies? Did we have see indicators in our soil sampling and so forth? Were there insect disease or pathogen of any kind operating in this field? And where were they in relationship to this output? The next style of map that we find helpful is, again, same data, click one more button, and we get what we call a grid or surface map. This grid does not relate to grid sampling in any way. It just is where we break the field up into tiny little grids or cells, often 30 or 60 feet or any dimension that is worthwhile for you. And any points falling in that little grid are averaged, and we look to find relationships between each of those little cells with the surrounding area. It's used as an analytical layer or a comparative layer. The other representation that you will see is what we call a contour map. And both the grid and the contour are more smooth data. We take out that really lively, speckly looking map, and we look for the data trends. This is the type of map that we could then turn into a variable rate prescription or other forward-looking uses. So what do you need to do to get this kind of information that you can start leveraging for learning more about how the field is behaving? My mantra is log it, map it, keep it, share it, but most of all, look at it. Data needs a place to live, so you need some kind of a software or viewer to store it, preferably be able to tidy it or clean it up, view it, query it, be able to look into those little sections and find out where those differences and what's the magnitude of the difference between your highest and lowest areas. We can then make reports, we can run analyses, we can create prescriptive maps, and this can either be done on farm or in cooperation with a service provider or a trusted advisor, crop advisor, those types of people who usually have the software that can do it. To review, if you're using guidance, you're collecting topo. So even if you haven't gone as far as the yield monitor yet, what data do you have? You can very often reap some rewards from the data you're already collecting. And once you can view your maps and view your maps in a different way, we can start understanding just simply by changing the perspective. In all cases, looking at yield over topography is a useful tool. So think about that as you're planning your data collection possibilities. Again, whether it's normalized yield or whether it's actual yield, we have all of these tools by the simple act of collecting that data from your monitor. We have all sorts of possibilities of where to go after you have that data. Once we are looking at different kinds of data, Bill, of course, mentioned that we have different types of information, and I'm really excited to hear that they have added the product temperature as one of the measurements that's being logged while we're out. This particular map is the same field, but instead of looking at yield, we're looking at a productivity or acres per hour from the information. And you'll notice that the slowest and lowest productivity was down below 4 acres an hour, and we had a higher efficiency area in the 8 to 10, although the average was somewhere around 5 to 6 acres per hour. This is, again, an operational tool that you can maybe help to improve your efficiencies or relate to the quality of the harvest from the yield information. The other operational diagnostics might be something like speed, the product temperature that he mentioned, or even load IDs. We can get as granular as looking at pass-to-pass comparisons. This is a really close-up look at every pass and the direction of travel as we passed up and down. We can basically recreate our each pass of the harvester by zooming in and using the tools that software provides us. But backing up, once we get away from the point-by-point interesting information, one of the most exciting things about map data is that map is actually a calculator. We can use this information to, as I mentioned, create one map from another. One of the biggest uses many of my clients are making of their yield maps is to actually calculate their crop removal. So here's one example. Here's a map. The yield range was between 2 and 550 hundredweight per acre. So that means the K2O removal would be between 75 to 410 pounds per acre of K2O was removed from this particular crop, which means we've got a variance in how much replacement product we need to augment what we've taken out. The average yield, if we'd only used average yield as a calculator, we would only be replacing 300 pounds per acre. Another example, again, wide-ranging yield. If we only used our average yields as a calculator of 288 pounds of K2O removed per acre, we would be missing some opportunities at one end of the scale, and we would potentially be over-applying at the other end of the scale. So using our yield maps as calculators for actual crop removal allows us to fine-tune our recommendations for subsequent crops. So mapping it is key to being able to reap some use out of these maps post-season, and we can use them not just in the immediate year, but in subsequent years as well. To summarize, I have 8 yield data tips to follow, and these work about as much for other crops as they do for potatoes. But my recommendation is to collect as much map-based information as is possible and practical from your operation. And the yield map is more or less the ultimate data capture. Always keep a copy of original or source data from your field, and preferably house it in a computer software that allows you to view it, edit it, and store it for the long term. You should always follow good data hygiene, which means using the best accuracy GNSS, Global Navigation Satellite System, or GPS possible for that task. You should always use the recommended calibrations, and I was very thrilled to see how easy it is to set up the calibrations for the GREENTRONICS monitor. And you should always know and understand, read the instructions for the setups for your particular equipment. If the service provider is offering a service plan, buy it and use their resources. Learn from them. Keep your in-field and in-office data management software current, and make sure you back up your data to a safe secondary location. If you're using a service provider, ask them to provide a copy of digital map files, not just paper, so you can combine them with your own records. Commit to learning new ways of using this information. I've just highlighted a few of the most common ways of starting to use these maps, but every time we have a yield map, we in effect have our revenue map. And we can develop a profit map very easily once we have that crucial yield information. Don't wait for a perfect system, whatever that means, to be complete. It's all part of a fluid and ever-changing process. And there's always benefits. Get on the elevator whenever you can and start riding that learning curve. In all cases, team up with your service providers or your colleagues to share data, share learning, and share the insights that you see with your maps. Actually look at the maps and information. Ask questions, be curious, and become map literate. And it's most exciting when it's your own maps that you're seeing, not something that you're seeing in an external presentation. I feel that of all the georeference data that can be used as a basis for unlocking potential, yield data is key. And so back to you. Concentrate on your small data. Get as much of that for your own self as you can. Use your local talent. Try new tools. Keep it for yourself, but also share it so that we can all learn from this exciting technology. And that wraps me up, Carrie, and I'm looking forward to questions.
Thanks so much, Karen, for your presentation. Audience members, if you've not already done so, please type your questions or comments into the chat box, also indicating to whom the question or comment is directed. And I think that we'll begin with Bill. And Bill, the first question that we have here is, would it be possible for Trimble to have an option of showing data in kilograms instead of pounds? They haven't been able to find that option so far. What do you think?
Oh, absolutely. Yeah, that's one of the choices in the menus. You can choose, as I said, you can do kilos per hectare, tons per hectare, pounds per acre, hundredweight per acre, and tons per acre. So there are all those options available. When we export into Trimble and John Deere, we are a little bit limited because of the way they've structured their software. So we have to export in pounds per second to those devices, and then data are interpreted from there. Does that make sense? Does that answer the question?
Yes.
I hope
Yes.
so. Yeah.
Thanks so much, Bill. We have another question for you here. How much area can be covered by the yield monitor, and what's the approximate cost of the system?
There's no limit to the area. We can collect data all day long and all year long. I suppose if we ever filled its memory, you might have to offload the data and erase the memory and start again. That I suppose that's possible. That hasn't happened to us yet, but it could, I suppose. The cost of the system is something. Yeah, of course I get that question a lot. I don't feel very comfortable answering it in a presentation like this. Usually that question gets asked from a dealer, and then we do some quoting back and forth, and the dealer organizes a number with the customer. It depends, of course, on whether the dealer is involved with the installation and setup, whether there's freight costs, whether options are needed or not, and so on. So if this question, wherever it came from, feel free to send me an email, and I'll be happy to work with you on that.
Thank you so much, Bill. And these next two questions, Karen, we'll start off with an answer from you, and then Bill, if you want to add anything after that, that would be excellent. So Karen, here's a comment. We're working with the yield monitor from GREENTRONICS. We had several areas that showed a yield difference of 400 hundredweight per acre over a course of 12 feet, which seems to be artificial. What could be the cause of it, and what are ways to clean or identify these areas in SMS or other software?
Well, that's a great question from Ruben. I'm not even sure I can tell you how many ways that can happen, but we do consider that a data anomaly. If you have sort of irregular hiccups, so every now and then it just jumps and then it jumps and then it jumps, I'd probably look to my calibrations or the load sensor just to make sure that everything was set up properly. If those hiccups, I'm going to call them, happen a lot and they happen sort of at regular intervals throughout the data collection, that's one thing to look at. But if they're just random, here and there, you have two choices. In SMS, yes, you can say, please select all yield above X amount and see what that pattern is and either elect to delete them or to scale them down to a more realistic max. And, or sometimes just looking at it in that grid or contoured configuration smooths those hiccups out, smooths those anomalies out, averages them in with the surrounding information. As we know, sometimes we get a bit of a pile up at the end of a row, for instance, or at end before you offload. There's certain instances in the field where all of a sudden we've got a surplus of crop on the belt. So sometimes it's those factors. So again, you can either average them out, let them sort of average into the surrounding data, or you can exclude them from analysis. So those are two options. And in SMS, you simply select the point in the editing tool and either delete it, or there is a scaling function that you can use. So hopefully that answers that question. And when you exported the yield data from SMS, I'm going to your second question, into shapefile format, we obtained a file with 8 identical points in a row across the swath width. Now this sounds like it must have come from a 4000 series John Deere. I'm sort of asking if you wanted the answer to that, Ruben. I think that's the only monitor that will give you that type of data across a header rather than just one. And it is a benefit/detraction for that particular monitor when it comes to looking at the data. It doesn't skew anything else other than the visual, but there are a number of techniques that we can do to make it a little attractive map. But that's generally it's a 2630. Well, I stand corrected then. I am surprised by that. Another option, if it's problematic for you, is that you can take your data directly off of the GREENTRONICS monitor. You can export it directly using, they have a USB that you can take it directly off their monitor rather than the John Deere, and import the CSV, and you will only get a single point per point collected. Okay.
Thank you.
So hopefully that gives you a couple of ideas to go on.
There is another question here, Karen. Which statistical software programs can Ag Tech work with?
Me personally, well, I tend to stick with the AgGIS programs and or Excel. I don't get into very much advanced statistical work through my company, but because we concentrate on the mapping end of it, and then anything that we want to do advanced statistics, we'll either export that data into a stats package, or I will use ArcGIS if I need something a little more advanced. That's the other program that I would use if I needed an advanced analytical tool.
Excellent.
That's not a farmer-friendly type program, but if the question came from a researcher or academic, that's very often a program that they would use for geostatistical work.
Thank you. Thank you so much. And Bill, did you have anything you wanted to add to that?
Regarding the problem that this person noticed, is yield jumping up and down over a very short distance. Yeah, I think Karen addressed that really, really well already. It's quite possible. We log data constantly with the yield monitor, so we get output from the load cells at 60 times a second, and then we average, and we can give that average to you each second, and so you can see those jumps because that's what gets recorded. It's possible to, with our newer software on the newer systems, to lengthen out that time interval so you don't record every second, but then you record every 3 seconds. However, if you're connected with Trimble or John Deere, we have to output every second, otherwise it messes over on their end. But yeah, you can change those times very easily on the GREENTRONICS side, and that might help those numbers a little bit. On the mechanical side, yeah, it can happen that if you're using a roller, a weighing roller, and you get a little stone wedged in there or a lump of dirt for just a moment, that will make a big difference, and you might see a sudden jump. That can happen, and I've seen that happen before. So Karen addressed already how you deal with those data, and I think that's 100% right. If you can tell that you have an anomaly, you need to remove it from the map, or else it will mess over your data. But I would look for mechanical issues and try and deal with them. If it's possible to run the belt empty right there, if you notice it while you're harvesting, run it empty and check your Tare calibration. Make sure we still know where zero is.
Thank you. That appears to be all the time that we have for questions today. And first, I'd like to thank our guest speakers for sharing their insights and expertise during this SpudSmart webinar on potato yield monitors. And I would also like to thank our sponsors today, BASF and McCain Foods, for their support. This webinar will be available on spudsmart.com if you would like to view it again. And on behalf of our team at SpudSmart, I'd like to thank you all for participating and also for your patience during our technical difficulties. And I hope you go on to have a fabulous day. Thanks so much.
Thank you.
Thanks, Carrie.